Alright, in this video I'm going to address the last topic in chapter 15, especially in 2x2 production model. And with that, chapter 15 culminates finally. So I went to the details about this 2x2 production model because I thought you guys you guys have seen the pure exchange economy, so Edgeworth-Box economy, and or Robinson Crusoe's economy in undergraduate microeconomics class, because those two topics appear on in the, for example, variance textbook. But this 2x2 production model is way complicated than, way more complicated than the previous two examples. So that doesn't appear in any undergraduate textbooks. So I've never seen, some undergraduate textbook dealing with this 2x2. Uh, so it only appears in a graduate textbook. So that's why I went to details about this economy. All right. So the remaining topic is about comparative statics analysis. So now in this video, we are doing two exercises. The first exercise about how does a change in the price of one of the outputs affect the equilibrium factor prices and the factor allocations. Okay? So think about a change in output price, say price of good J. Okay? And how does it affect equilibrium input prices and equilibrium factor allocation? Okay, that is the first exercise. And the second exercise is how does a change in the total endowment of one of the two factors affect the equilibrium prices and output levels? So in this exercise, we investigate two derivatives. So the derivative of input prices with respect to total endowment, okay, say a factor I, and the derivative of quantity produced with respect to the same variable. So the total endowment factor I. Yeah. So each exercise leads us to one theorem. So especially the first exercise brings us to the so-called Stolper-Samuelson Theorem. Okay. And the theorem states that in the 2x2 production economy with the factor intensity assumption, so we maintain factor intensity assumption. So we may assume firm 1 is relatively more intensive in factor 1 than firm 2. Okay? And imagine that price of output J increases. So suppose P sub 1, so price of a good one increases. Okay? And how does it affect input prices? First, so equilibrium input price, so equilibrium price of the factor more intensively used in the production of a good J, because now we consider a good one, good one. So W sub 1, because from 1, so the production of a good one is more intensive in factor 1. Okay, so by the first statement, we know W sub 1 increases. Okay, and on the other hand, the price of the other factor, so W sub 2, decreases. Is it a natural consequence? I mean, is it quite consistent with your intuition? Is it quite a intuitive result? Think about the change in output price again. If P1 increases, then from 1, because selling this a good one, marginal benefit from selling now increases. And of course, the firm 1 has a more incentive to expand its own business by producing more. So in order to produce more, firm 1 has to employ more inputs. So we can anticipate Z sub 1, 1 and Z sub 2, 1. So firm 1's demand for each factor both increase, right? But firm 1 is more intensive in factor 1, right? So the production of good 1 requires a more factor 1 rather than factor 2. So the demand for factor 1 increases a little bit more than demand for factor 2, like this. Okay. Anyhow, the demand for each input increases, so we can anticipate, the price of, price of both factors increase. W1 and W2 both increase because now demand increases. Demand for both factors increase. Yeah, but this is not the end of the story because not only firm 1 but firm 2 also exist in this economy. Right? So we have to think about how firm 2 responds to this change in upper price. Okay? Because firm 2 knows that firm 1 expands its own business by employing more inputs, so both inputs will be more expensive. That increases firm 2's marginal cost. The unit cost of C2 will increase. Okay, so firm 2 will respond by producing less. Okay, so the demand for input Z sub 1, 2 and Z sub 2, 2, firm 2's demand for both factors will decrease because firm 2 knows firm 1 will expand by employing more and more. And the total endowment of each factor is limited. There's no change in the total endowment. So given the total endowment, firm 2 now expanding by employing more inputs. Okay, so now the inputs are more scarce, so that increases marginal cost of firm 2. So the firm 2 will respond by producing less. All right. So there is a quantity effect. This kind of quantity effect, I call that general equilibrium effect, because now we're considering interaction between these two firms. So due to this quantity effect, Z12 and Z22 both decrease, right? But firm 2 is more intensive in factor 2. The firm 2's production is more intensive in factor 2. So we can anticipate Z sub 2, 2, firm 2's demand for factor 2 decreases a little bit more than Z sub 1, 2, demand for factor 1. Right? This is why W sub 2, because this quantity effect dominates this firm 1's incentive to expand business. Right? So this is why we have a decrease in the second factor, or the decrease in the second factor's price. W sub 2 decreases. Okay? And this result is well visible in this diagram because there is no change in P2, so we can work with the same level curve of C2. Firm 2's unit cost function, the level of firm 2's unit cost does not change at all. But P1 changes, so price of good 1 increases from P1 to P1 prime. So the level curve of firm 1's unit cost function will shift up like this. Okay? So we have a new intersection. Remember, the input prices are determined at the intersection between these two level curves. Okay? So the intersection changes from this point to this point. Okay? So there will be transition. So there will be a transition of the intersection. Okay? So as a result, the price of factor 1 increases and the price of factor 2 decreases. Okay, because now the level curve of firm 1 will shift up. Okay, so the new intersection will be right here. Okay, so the price of input 1 increases, but price of the input 2 decreases. So that is a geometric so geometric, geometric interpretation of this theorem. So now the result of this theorem is visualized by this diagram. Then what about a factor allocation? Because now we have a new intersection, so the slope of the this level curve will be different. Okay, so previously at the intersection, the slope of the level curve, say from 1, is a little bit steeper than at the new intersection, right? So that means the slope of the level curve, a sub 1, 1 over a sub 2, 1, that will decrease. The magnitude of the slope will decrease. So that results in, the more steeper ray from the origin O1. Okay, and from 2's the slope of the from 2's level curve also decrease. So meaning that level curve will be flatter at the intersection. So the ray from origin 2 also decreases. I mean, the slope of the ray from origin 2 also decreases. So that leads us to a new intersection in the attribute box right here. Okay, so we can see the new factor allocation. Previously, the factor allocation was here, so we can easily see from 1 increase the demand for both factors. Okay? Z11 and Z21 both increase. Okay, and for from this origin, we can easily see from 2 will produce less, because by employing less input. Okay? Z sub 21, Z sub 1, 2, and Z sub 2, 2, the demand for both factors decrease. All right, and also we can see the effect on quantity produced. So from 1 will expand its own business. The isoquant passing through this allocation is right here, the previous allocation. But at the new allocation, isoquant is way above, right? So meaning that from 1 will produce more, okay? And from 2, producing less. So this isoquant, so now the new isoquant at the new allocation will be below the previous one, okay? So this is a Stolper-Samuelson theorem. The exact proof is not that difficult, and it's pretty short and simple, so I'm going to do that. So here we have two equilibrium conditions regarding input prices. So input prices determined by these two level curves. Okay. So now I'm going to do total differentiation of these two equations, two conditions. So remember now, P1 is not constant because now we are considering a change in output prices. Okay. So with that in mind, if we do total differentiation, so then we are going to get A sub 1, 1 dW1 plus A sub 2, 1 dW2 equals dP1. So total differentiation of C1 gives us, remember Shepard lemma, the partial derivative of C1 with respect to W1 gives us conditional factor demand function given the target quantity, single unit, so A sub 1, 1 and A sub 2, 1, okay? And similarly, if we do total differentiation of this new, the second condition, then we get A sub 1, 2 dW1 and A sub 2, 2 dW2 equals dP2. Okay, so we come up with a system of linear equations, right? So we can translate into a matrix form. So dP1 and dP2, we have 2 by 1 matrix on the left side, and on the right side, I mean, these two equations can be expressed as a matrix multiplication. So matrix A and the variable dw1 and dw2. Right? And now the factor intensity assumption kicks in. So the law of a factor intensity assumption is, because a factor intensity assumption tells us a sub 1, 1 over a sub 2, 1. So the ratio of factor uses by from 1 is always higher than the ratio of factor uses by from 2. So 1, 2 over 2, 2. Right? So if we do cross product, we obtain a sub 1, 1, a sub 2, 2, minus a sub 2, 1, a sub 1, 2 will be greater than 0. Okay? But this is nothing but determinant of this matrix. Let me call this matrix A. Okay? So the factor intensity assumption implies this determinant, this matrix has non-zero determinant, especially positive determinant. So the inverse matrix exists, right? So now we are looking for this dw1 and dw2. I mean, how input prices change in response to change in output price. So we need to solve this equation for dw1 and 2. Okay, so the way to solve that is pre-multiplying that inverse function, inverse matrix, to both sides. Okay, so dw1, dw2 is going to be A inverse times dp1, dp2, right? But the inverse matrix of a 2 by 2 matrix is a 1 over determinant times, we need to switch these diagonal entries. So A22 and A11. Also, we have to interchange these off diagonal entries, and we need negative signs. So negative A21 and negative A12. So I think you guys remember this formula, the inverse matrix of 2 by 2 matrix. Now I'm teaching this in the other class. So math for economists, for sophomores and freshmen. Anyway, so now we have an inverse function. So now the only thing we have to do is multiplication of these two matrices. So multiply by dp1 and dp2. Gives us dw1 and dw2. So dw1, change in input price, so change in price of factor 1 is going to be 1 over determinant times A22 dp1 minus A21 dp2. And dw2, the second entry, is going to be 1 over determinant A, negative A12 dp1 plus A11 dp2. Right? And remember, we considering change in price of good one. Okay, so there's no change in price of good 2. So dp2 is 0. So these two terms goes away because dp2 is equal to 0. Okay, and remember, all a's are positive because they are demand for factors. Okay, and determinant of A is positive. So dw1 will be positive. Okay, because we consider increase in P1, right? So dp1 is positive. But dw2 will be negative due to this negative sign. Okay, so that's the so this is the proof of Stolper-Samuelson theorem. I think this is not that long and very simple. And there is some interesting, matrix algebra here. So I showed you the exact proof. Right? And the next theorem is, so next theorem concerns the second exercise. If a total endowment changes, how does it affect equilibrium prices and equilibrium factor allocation and the quantity produced. All right? And that is a Rybcszynski theorem. So the second exercise brings us to Rybcszynski theorem. Yeah, I'm not sure about the pronunciation. I think he's Polish or Russian. Let me call this Rybcszynski, right? So the theorem states that in the 2x2 production model with the factor intensity assumption, if the endowment of factor increases, so here this diagram shows us the increase in the endowment of factor 1. Okay, so the edge of the box gets larger horizontally. Okay, previously endowment was z1 bar, and now we have a z1 bar prime. Okay, so the length of the box now increases. Then what happens? So the production of the good that uses this factor relatively more intensively, that is a firm one, I mean good one. So price of good one, production of the good, so Q1 increases. Q1 increases. But Q2, production of the other good, Q2 decreases. Okay? And what about your input prices? As remember, input prices are determined by these two conditions, right? And these two conditions are independent of the total endowment. So we can work with the same ray from the origin, because this ray is determined by, just the input prices. But there is no change in input prices. So there's no change in the ray. Okay? So before this endowment changes, the intersection was right here. Okay? But after change, we have a new intersection right here. Okay? So, because from one, production of good one is more intensive in factor 1. But there is more factor 1. So intuitively, from 1 will expand its business. So by producing more. So the isoquant passing through this point, from 1's isoquant passing through the previous allocation is way below that isoquant passing through the new factor allocation. So Q1 increases. It's not that surprising at all, because from 1, so production of a good one is more intensive in factor 1. Now there are more factor 1. So it's a nice opportunity to expand the business, right? But the second part, what about firm 2? This is not that trivial. Why firm 2 produces less? Okay, I mean, in this figure, it's not that visible. So firm 2's isoquant passing through the previous allocation was here. Now here, it looks like the isoquant falls, so Q2 decreases, but origin also changes. So we have to read this point. At the same origin. So this is not that easy job in this diagram. But going back to previous exercise, so the 2x2 economy, production economy with Cobb-Douglas, we have an expression for factor allocation, equilibrium factor allocation for firm 2 right here, right? And think about Z1 increases, Z1 bar increases, okay? Then Z22 and Z12 both decrease. Okay, so the firm 2 employ less input than before, so producing less. Okay, and this is not that intuitive. Why firm 2 has to respond by producing less? Okay, I mean the first statement of the theorem, if there are more inputs, there are more factor 1s than firm 1, producing good one, and the production is more intensive in factor 1, so we'll produce more. Okay, so that is quite intuitive, but the second result is not that intuitive. So this is going to be one problem in the first problem set. So I'm planning to post a problem set this weekend at the latest, and we'll give you plenty of time. So don't worry about the deadline, okay? But I wish you think about economic reasoning behind this theorem, especially the second statement. Why does firm 2 respond by producing less in that situation? Okay, you need to think about general equilibrium effect. Okay, so that is going to be really nice exercise. So strengthening your economic reasoning. So you don't have to show any proof. Okay, but you have to provide some, some intuitive story explaining why firm 2 responds by producing less. Okay. Anyway, this is the end of chapter 15. So now in the next video, we are going to deal with a little bit more general framework. So generalizing the previous insight we studied in the last week and this week. So especially the welfare theorem, the welfare properties of general equilibrium. All right. Hope you guys enjoyed this video and see you guys in the next.